Hello, this is Mrs. Phelps going over section 11.5 on the law of cosines. This is my 5th time trying to record this video because I'm still getting used to it, so bear with me if things are not as smooth as they should be. This first video is going to be going over finding the missing pieces of the two triangles and determining how you can solve those. The second video explains the law of cosines, where it comes from. The third video explains when you can apply the law of cosines and a few practice problems along with that. And the fourth video is going to be covering when to use different laws, whether to use the law of sines, the law of cosines, and some problems solving the triangles. It's also going to cover the ambiguous case and what that would look like if you use the law of cosines. So this first video, we're going over these first two problems. You can print section 11.5 notes, which are in the folder, or come up with another way to follow along. So looking at this first problem, it says find the missing pieces in the following triangles. And finding the missing pieces means that we are solving the triangle. We've already got, for this first problem, we've already got the sides. Side A is 8, side B is 11, and side C is 6. The question is whether or not we can use the law of sines. And to recap on the law of sines, you either need to have two angles and any side. If you have two angles and any side, then you can solve for the third angle by subtracting from 180 and then use the law of sines. Or if you have two sides and an angle opposite from one of them, then you can use that information to solve for the other angle, again using the law of sines. This problem here, we don't have either of those combinations. We've just got the three sides. So we have to use the law of cosines. And to recap on the law of cosines is a squared equals b squared plus c squared minus 2bc cosine of angle A. And this is written in the form of if we were solving for angle A to start, or if we want to solve for a different angle, then we just need to rewrite it in terms of that angle. So we're going to be starting by solving for angle B because it is across from the longest side. So we need to write this equation in terms of B. That is side B squared equals A squared plus C squared minus 2 times A times C times cosine of angle B. And here we're solving for angle B, so we can go ahead and plug in the sides. We've got B, A, and C. 11 squared equals 8 squared plus 6 squared minus 2 times 8 times 6 cosine B. Now we can simplify. And remember here, we've got 100 minus 96 times the cosine of B. Negative 96 times the cosine of B is multiplication. That's 100 minus that quantity. So following PEMDAS, we have to get rid of the 100 from both sides before we can divide by negative 96. You cannot do 100 minus 96 because the 96 is multiplied by the cosine of B. And if you continue solving, angle B comes out to 102.6. And we want to solve the triangle, which means we now need to solve for angles A and C. From here, we can use the law of sines since we now have an angle and two of the sides. One of the sides is across from the angle. So we can set up the law of sines. So since we know angle B is 102.6, we've got sine of 102.6 over side B, which is 11, equals, and then I'm doing angle A, so that's sine of angle A over 8. Go ahead and cross multiply and solve for angle A. This comes out to 45.2 degrees, and remember for angles we're rounding to the nearest tenth of an angle, or nearest tenth of a degree. And to find the last angle, since we know two of the three angles, we can just subtract those two angles from 180. 180 minus 45.2 and 102.6 comes out to 32.2 degrees, and this is angle C. So this is problem number 1. Go ahead and try problem number 2. Just to recap, can we use the law of sines on problem number 2? No, we cannot. We've got side angle side here. We don't have the side across from the angle that we know, and we don't have any angles across from the sides that we do know. So we need to use the law of cosines for this one. Go ahead and pause the video and see if you can figure this one out. Remember, you're solving the whole triangle, so that's all of the missing parts. We want to start by writing the formula in terms of c, since we have angle c is 40 degrees. So we've got c squared equals, and that's side a squared, which is 7 squared, plus b squared, that's 5 squared, minus 2 times 7 times 5, cosine of 40. And when you simplify this, comes out to c equals, we need to do the square root of the right side, and the square root of the right side is 4.51. And remember, for side lengths, we want to round to the nearest hundredth. So side C is 4.51. Now that we've found side C, we can go ahead and use the law of sines to find angle A or angle B now. And when you simplify this down, we cross multiply 7 times sine of 40 divided by 4.51. We have to take the sine inverse of that to get angle A, and angle A comes out to 86.1. And now we've got two of the three angles. We've got angle A and angle C, so we can go ahead and solve for angle B by subtracting from 180. So angle B comes out to 53.9 degrees. And we've solved these two triangles. This wraps up part 1 of 11.5. Go ahead and do the assessment, and then I will see you in part 2.